Let's talk about long division, and then that will help us with our polynomial division. So long division, which hopefully you learned in elementary school, we start basically by saying, how many times does 3 go into this first number? 4. Now, of course, it's representing 40, but we'll come back to that in a second. Well, 3 goes into 4 exactly, well, not exactly, goes in one time. And then we basically have to figure out, okay, if it goes in one time, how much were we off by? And the way we figure that out is we multiply 1 times 3. Obviously, the opposite of division is multiply. 1 times 3 is 3. And we subtract to say, well, how much were we off by? We're off by 1, which hopefully makes sense. I mean, 3 goes into 4 one time, but there's 1 left over because 3 times 1 is 3, and we didn't get 3. We're trying to get into 4. At this point, we drop the 6 down, and we say, how many times does 3 go into 16? Well, 3 times 5 is 15. That's as close as we're going to get. So I'm going to put a 5 here. And we just repeat our process. We say, okay, 5 times 3 is 15. So once again, we were off by 1. Now, we don't have any more numbers here to drop down. Now, if we put like a decimal and a 0, we could drop down a 0, and we could be doing this as like a decimal point. We could be figuring that out. But instead, I'm going to say this is a remainder. Okay? So there are a couple of ways we can write our answer. We can say it was 46 divided by 3 is equal to 15 with a remainder of 1. Or we can say it's 15 with 1 out of 3, 1/3 left over. Okay? Just our remainder is the numerator, and our divisor, 3, is the denominator. Let's use that same idea to divide polynomials. All right. Now, I would think about this way. We have this function, this cubic function, third degree polynomial, being divided by this line, x minus 4, this linear factor. I would say, okay, 2x cubed divided by x. So imagine you just put like divide by x. What is that? Well, that would be 2x squared. Now, the difference between what we just did with numbers and this is this, when we multiply 2x squared times x, this should be an absolute perfect match. We're going to get 2x cubed. Now, this also gets multiplied by -4. Now, with everything with polynomials, remember what the most important thing is the highest powered thing. So we care about dividing this x out, 2x cubed divided by x. The -4, that's immaterial to us, really, as we figure out the division. But we do have to account for it. 2x squared times -4 is -8x squared. Now we're going to subtract that entire thing. Well, 2x cubed minus 2x cubed is 0. 4x squared minus a negative, so just notice the minus a negative is plus. This is going to be 12x squared. And then I'll just bring the rest down exactly as it appeared. Now we repeat our process. 12x squared divided by x. So imagine just divide by x. It's going to be 12x. And we multiply. 12x times x is 12x squared. 12x times -4 is -48x. We're going to subtract. Once again, this is 0. It needs to be 0 or we didn't do it right. And then we have 3 minus a -48, so that will be 51x, and I'll bring down that -7. 51x divided by x is 51. So we multiply. 51 times x is 51x. And 51 times -4 is -204. This subtracts out. Negative 7 minus a negative 204 is 197. Now you'll notice at this point that 197, we can't divide that by x really, so we say this is our remainder. Another way to write that, if I could maybe move all this over for a second, would be to say it's our answer, 2x squared plus 12x plus 51, plus our remainder over our divisor, like that. Now, I just want to point out, if you wanted to work backwards from this, if you said, well, how would I get back to this original polynomial? If you put this whole thing over 1 and got a common denominator, so you multiplied this by x minus 4, and then, multiplied it through, combined your like terms, added 197, you would get back to this original polynomial. So essentially, we have split this apart. Often this is for factoring purposes, and calculus this is for integration purposes, but we sometimes like to split it apart in order to have something different to work with, which maybe can help us. Let's do one more example. All right, let's say we have this polynomial, 4x cubed plus 3x plus 2, and we're dividing it by x plus 1. I want you to notice we're missing a term. We don't have an x squared term. I would want to have an x squared term. Here's what I'm going to do. I'm going to just erase the 3x plus 2, and I'm going to put a placeholder, 0x squared, and then I'll put the 3x plus 2 back in. Okay? But that will help us line our problem up. You'll see why here in a second. Okay? All right, let's take 4x cubed and divide that by x. That is 4x squared. We multiply 4x squared times x is 4x cubed. 4x squared times 1 is 4x squared. So now you'll see we got that lined up under our 0x squared, so we can keep our like terms together. 0 minus 4x squared is negative 4x squared. I'll bring the rest down as it appears. All right, negative 4x squared divided by x. Well, that's negative 4x. Negative 4x times x, negative 4x squared. Negative 4x times 1 is negative 4x. We're subtracting that whole thing to figure out what is left over. 3x minus negative 4x is 7x. Bring the 2 down. 7x divided by x is 7. And now, of course, 7 times x is 7x. 7 times 1 is 7. Subtract. This is 0. 2 minus 7 is negative 5. That is our remainder. And again, another way we could write this is we could say our answer is 4x squared minus 4x plus 7, and then plus negative 5 over x plus 1, our remainder over our divisor. Again, if you put this over 1 and then got a common denominator and put it all together, you would end up back with this. So that is polynomial division. If this video helped you, please like and subscribe for more math help.